All right, we're going to work on absolute values right now. An absolute value, the definition of that means the distance from zero. So imagine that we have 2 points, one at -3 and one at 3. If one person is standing at -3, how far do they have to walk to get to 0? They have to walk 3 whatever, so we'll call it 3 feet. If they're at 3, to get to 0, they have to walk 3 feet. It's the same. And that's how we talk about things, especially in terms of distances and in real life. We say we are 3 feet from something, not -3 feet. Now, there are times and there's uses definitely for negative values, and that's why we have them. But an absolute value is just the distance from 0. We're just talking about the distance to something. So -3 is equal to 3. And +3, the absolute value of that is equal to 3. So the absolute value of -3, 3. The absolute value of +3, 3. So notice we don't change the sign every time necessarily. We only speak in the positive terms. So for instance, let's say we have the absolute value of x is equal to 5. In order to solve that, we have to consider two things. And so when we solve absolute value equations, we're going to have to say, oh, two separate things. X could be +5 inside of here, or x could be -5. The way we say that, we have two solutions, positive or -5. So x in this case would be equal to positive or -5. Two answers, two solutions. Say we have an equation, an absolute value equation set up right here for part A. What we're going to do is once we simplify something so that we have it just down to absolute value signs on one side of the equation, then we can set up two separate equations to solve. And it's going to go back to this positive -5 idea. So one equation that we set up is x minus 3 is equal to 5, just as it is. Or we can have x minus 3 is equal to -5. We're going to solve both of these, and both values of x will be an answer. We'll put it back in and check at the end. So in both of these equations, we're going to add 3 to both sides. This one we get x equals 8. And in this one, we add 3 to both sides. We get x equals -2. Now, how can both of these be solutions? Well, it's the way that we'd work these out. Imagine that we put 8 right there. 8 minus 3 is +5. The absolute value of +5 is +5. So that one works out and checks out. The next one that we'd get, -2 minus 3 is -5. And then we would take the absolute value. -5, the absolute value of -5 is 5 as well. Both of them check out. Both of them are solutions. Part B, let's work on this one. Now remember I said we have to get it to absolute value only on one side before we can do our two separate equations. So in this one, -2 is, treat these almost like we would parentheses, except they mean absolute value. -2 is multiplying and distributing to these. Well, it can't actually distribute to those, so what we have to do is divide both sides by -2 first. That side by -2, this side by -2. That cancels out the -2 right here, and we're left with the absolute value of x plus 4 is equal to +5. Now we can set up our two separate equations. X plus 4 equals 5, and x plus 4 equals -5. We subtract 4 from both sides in the equations. X can equal 1, and then subtract 4 on both sides here. X is equal to -9. Now we check those and put them back in and see if they would work in the original. 1 plus 4 is 5. The absolute value of 5 is 5 times -2 is -10. That checks out. -9 plus 4 is -5. The absolute value of -5 is +5. +5 times -2 is -10. Both check out. Now, think about one last thing. This cannot happen. The absolute value of x